This is lecture 4, and we will be talking about how to read data into SAS. So usually when you get a data set, it's not going to be a SAS data set. Occasionally it will be, but more often than not it won't be. So it'll be in some other file format. So let's start by talking a little bit about the different ways that files can be stored. So broadly speaking, there's two types of files in this world. There are text files, and then there are non-text files. So text files are very good because they can be read by just about any program. So with a text file, it's kind of like a universal format that any program can understand. So Word can understand it, Excel can understand it, Access can, SAS, SPSS, and so forth. Now, proprietary formats are formats that are specific to a certain program. So when you save an Excel file, it saves it using the Excel format, and it's going to give it a special extension like .xls or XLSX, indicating that this is stored in Excel's format. .doc is Word's format, SAV is SPSS's, and SAS7B data is SAS. DBase is a very old format. DBase is an old computer database program, and so the format that they use to store files is pretty common. So very often you'll get a DBF file, which is one of these database files. Okay, so there are proprietary formats, and then there are text formats. What are the common text formats? Well, anytime you see a .dat, .text, or .csv, it's probably a text file. And so again, the thing to remember about text files is that they can be read by any program, so it's kind of this universal format. Now, we're going to talk about both types, both proprietary formats, proprietary non-SAS formats, as well as text formats. So let's start out with text. There are two main types of text files in this world. There are delimited, and then there are fixed position files. So let's start out with what a delimited file looks like. A delimited file is set up where every variable is separated by some delimit character, often called the delimiter. Probably the most common is a comma. Tab is also very common. You'll also see semicolons and the vertical bond symbol, pipe symbol. But comma and tab are probably the most common. So here's the first few lines of a file that I once received. The first line in this file looks a little bit different from all the others. It's called the header. So the header just tells what's in every column of this data set. So the first variable is going to be ID. Then the comma is the delimit character that separates all the variables. The next variable is going to be the site name, and then the day ID, time ID, number of pages, and the duration that someone spent on that particular page. So you'll see if you look down below, you have commas separating the variables, and every record here is going to have 6 variables, so 5 commas in each row. So that's what a delimited file looks like. If we go over to Unix for a second, I am going to go over to our dataset folder. And I've added some files since the last time I made a video. In particular, I've added some files from the chapter 12 case, and we have it in just about every format under the sun. So I'm just going to cat it. Let's do a cat of case 12.csv, and what you'll see is that you've got all the values, everything's separated by commas, the variable names are specified at the top of the file. That again is the header row. Now I've also specified this is .txt. TXT is usually a tab delimited file. So let's just do a head on that one, case12.txt. And so what you'll see is that there are all these variables out there, and they're separated by tabs. if I VI'd that, let's go and VI it, case12.text, I'm just going to start hitting L. So these are one character at a time. Now the next L makes me jump, and that's because that's a tab. So that's one to the left, one to the right. So that's a tab character. And here's another tab character, another tab. All right. So all of the variables are separated by tabs. So those are two common delimiters. The other very commonly used format is called fixed position. So in a fixed position, every variable occupies certain columns, and then the person who provides you with the data has to give you a decoder. So for example, this comes from the California Pizza Kitchen data set, and the variable store ID is in columns 1 through 5. So we have to start counting 1, 2, 3, 4, 5. So those 5 bytes or characters make up the store ID. Question 1, the answer to question 1 is in column 6, which would be right here. Then question 2 is in column 7, and so forth. So that's what fixed position looks like. Now there's some advantages and disadvantages to both. The advantage of fixed position is that you tend to get smaller files as long as you don't have long strings. Okay, so the reason for that is you don't need to put additional characters in for the delimit character. So had I made this a comma delimited file, we'd have to stick a comma in between each of these values that would inflate the size of a line, and the file would get bigger. So those are the two main types. How do you get these in? Well, we've already seen some examples. Now we're going to kind of go through those examples systematically and explain everything. So we're going to do all of this in a data step. Here's the format for a data step. You're going to start out with the SAS reserved word data, and you've got to give it some name. So this name can be any valid SAS name. What's a valid SAS name? Well, valid SAS names must begin with a letter or an underscore. You can put any combination of letters, numbers, or underscores in the name. Don't put special characters. Don't put a period in there. Period's going to tell SAS it looks like a format. You can't put things like percent signs, pound signs, exclamation points. None of that stuff is valid. So in essence, it has to begin with a letter or an underscore, and then it can contain any combination of letters, numbers, or underscores within. SAS, unlike Unix, does not make the distinction between cases. So the variable sales in all uppercase is the same to SAS as the variable sales with just a capital S is the same as sales with all lower letters, as the same as this where the cases are kind of mixed up. So all 4 of those variables are identical to SAS. Okay, so that's what data name is. We're going to start out data, give it a name. Then we're going to have a series of statements, and we're going to close it with a run. And so run is what's going to tell SAS, go do everything I just told you to do. In SPSS, you don't put run, you put execute. All right, one other thing about indentation. Indentation is optional, but recommended. So the format that I follow is that I'm going to put data in the first column and I'm going to put run in the first column. All the statements that sit inside of a data step will be indented. It's not all that important which indentation convention you follow, as long as you follow one. So I usually use 2 spaces, everything in a data step gets indented, and it just makes the program much more readable and easy to maintain. So someone else coming in to look at it will be able to see that indentation and see where things sit. So more on indentation as we go along, but I would just be very consistent with what you do. Make your programs much more readable, and when you come back next week, it'll be easy for you to understand. So today we're talking about how to get data in. I think that there's really two basic steps. So the two steps are, first, you have to tell SAS where is the data, and then you've got to tell SAS where to find what. So which columns correspond to which variables. Now within where the data live, there are really two possibilities. So one is with the data lines statement. You could also say cards. Those cards is the old version, data lines is the new version, but SAS understands both. With data lines or cards, you're going to drop the data into the program itself. InFile, on the other hand, looks for the data in an external file. So let's go down below, and you see a little program that you've seen before. Data my data. So this says we're going to create a data set, and that data set is going to have the name my data. Since there's no libname, it's going to put it into the work library. Had I prepended something like sscc.mydata, then it would stick it in that sscc folder. Now let's skip over input for now. Let's go down to data lines. So the data lines gives all the data, and then we have a run. So there's 3 lines of data. Red, blue, green are the 3 colors. Second step is to tell SAS where to find what. So that's going to be done with an input statement. So we're going to say input color $. The $sign tells SAS that color is a string. So strings are any sequence of alphanumeric characters by default. Strings will have a length of 8, or at most 8 in SAS. So color $, is going to allocate 8 bytes to color. Then we're going to input a variable called x, another one called y, another one called amount. So when I print this, here's what you get. So SAS looks like it read it incorrectly. Now, let's talk a little bit more about these two places where you can, or 2 places that you can put your data. So data lines. As I said, data lines goes in the program itself. It's really good if you have dinky data sets. Don't do it when you have big data sets. Still very useful when you're learning how to, use certain commands. So it's very easy to just put a couple lines of data in, try it out, see how something works. So it's worth knowing. The other possibility is that you use an infile statement. So I will show you what an infile statement looks like. So let's say I've got this program, I've got this data set. I did this on a PC, so it was located in c:\ecm\junk.dat. That's the name of the file, and here's what it looked like. Now, in my SAS program, if I say data my data, it says make me a new data set, call it my data, put it in the work folder. Then infile. Infile just says, I want you to go to this file, c:\ecm\junk.dat, which matches what I had up here. That's where you're going to get your data. Don't worry about the lrec_l command. In fact, I think I'm going to delete that for your version of the course packet. Don't worry about it for now. Then everything else is the same, just input color, x, y, and amount. Let me talk about a few of these options around infile. So infile, like any other command in SAS, can take a bunch of options. Here are some of the options. You don't need to specify them all. Obs equals, so if you set obs equals 100, you're only going to get the first 100 observations. This is really useful when you're first reading in a data set. So if you get a giant data set with 1 million records from somebody, I would be sticking an obs equals statement on until I know that I have the SAS program right. The reason for this is that it doesn't take much time to read in 100 observations. It takes in a substantial amount of time and computational resources to read in a million. So get the program right, and then once you know you have the program right and everything's debugged, get rid of obs equals 100. First obs is another option that you'll use all the time. First obs equals 2 says start reading on line 2 of the input file. So ignore the first line. So you will be using this all the time when you have a header line. So go back to that case 12. The first line here is not like the others, and SAS is going to get really confused because if you try to read this in as numbers, well, temp isn't a number, right? TEMP is a bunch of letters. So we want to skip over that first line, begin on line 2. So I'd say first obs equals 2. Another command, so here's lrecl. lrecl sets the length of a line. The default is that lines can be at most 256 characters long. Now, anytime your lines exceed that, you have to set lrecl. So if you have, sometimes a survey will have a couple hundred questions, and you might have a line that's 1,000 bytes long, then you got to set lrecl to 1,000. Do this, because if you don't, you will get the most cryptic error message. The first time I struggled with this, I remember spending all afternoon trying to figure out why my program wouldn't run, and it was because I hadn't set the record length correctly. So most of the time you have pretty small lines, and then the default of 256 is fine. Otherwise, you're in trouble. Okay, DSD is used whenever you have a comma delimited or any sort of delimited format. We'll discuss more on this later. So let's talk more about the input statement. So we've talked about infile. Now input, recall, tells SAS where to find what. So the variable names have to be valid SAS names. Remember what a valid SAS name is? Begins with the letter and underscore. Can have letters, underscores, or numbers in it. Don't do special characters like commas, periods, star signs, or anything like that. There are really two main types of variables in SAS. There's numbers and there's strings or character variables. Dates are a special type of numeric variable. Now, when it comes to specifying where to find what, SAS offers 4 different approaches. So they're list, column, formatted, and comma delimited. So list or free input is what you've just seen. So let's go back here. I suppose you could say that this is a white space delimited file, but don't go there. All the variables are separated by at least one space or tab, and SAS is just going to input them. All right, so this is free input. All the variables are separated by at least one space or tab. Remember I said there were several types of files, delimited or fixed position. Okay, so the next 2 types, so column or formatted, read in fixed position. The last type, delimited, reads in this type. So let's just go back to this page. You're going to use column or formatted if you have a fixed column file. The database administrator or whoever cut the file for you will decide what to give you. And so sometimes you're stuck with one of these fixed columns, sometimes you're stuck with delimited. So then delimited is the last one. All right. One more thing. A period indicates missing, just as in SPSS. So we're going to walk through these 4 types of input. So let's start with free input. So here is free input. You just say input the variables, and the variables are separated by at least one space. So here I inserted some spaces just to show you that SAS would still work with this. So we read this, and we get exactly the same output. So columns need not line up with free input. Let's talk about column input. So that's about all I want to say for free. So column input works like this. If you have a file where the columns line up, and the database administrator gave you a decoder, then you're going to use column input most likely. So here's the input statement. You specify the variable. If you want a string, you put a $sign. Then you specify the start and optionally the end position. So that looks kind of abstract. Let's look at a little example and I think everything will be clear. So in this example, I have removed a lot of the spaces. What you will see is the first 5 spaces are for color. Then I specify that up here in the input statement, color $. The $sign means color is going to be a string, and SAS should find color in columns 1 through 5. Now X is in position 6, so this is the value of X, and if we go down you'll see that X reads that incorrectly. The values of Y are in column 7, so here's column 7. The first row, Y is equal to 2. Then amount is going to be a numeric variable since there's no $sign there, and amount can be found in positions 8, let's try that again, 8, 9, 10, 11, and 12. So those 5 characters specify the amount. And so that's how you do column input. I've changed the format slightly. I've added some space over here. And so what you'll see is that red is still, or color is now in positions 1 through 5, but X has been moved to column 7. Y is in column 9, and then amount is in 11 through 15. And so you get the same thing. At the bottom, I show you how to do this using SPSS syntax. So it kind of looks the same, except the letter A is used in place of the $sign to indicate that you got a string. A probably stands for alphanumeric, but everything else looks pretty similar. Pretty similar, except SPSS says begin data and end data and then execute instead of run. So begin data, end data instead of data lines, and then execute instead of run. Let's talk about the third way of bringing in data, which is called formatted input. With formatted input, you are going to use the @ sign. So you're going to say at a particular column, bring in some variable with a certain format. So let's go back to those 2 versions of that little data set that I had on the previous slide. However, here I'm going to bring in those programs, those data sets with formatted input. So at 1 just means at position 1. We're going to bring in color. What's the format for color? Well, $5. So $5 dot. So $5 dot, remember all formats have a dot in them. That just means 5 bytes and it's a string. At position 6, you're going to bring in 1 byte for X. At position 7, 1 byte for Y. At position 8, we're going to bring in amount, which is 5.2. I could have just said 5 dot and it would also bring it in correctly. The program on the right is pretty much the same, except we have to change these column numbers. So instead of 6, it's 7 and so forth. Let's talk about the fourth way of bringing in data. That fourth way is delimited. Here's the way you're going to bring in delimited. You must specify a file, as far as I know. So you got to use the in file if you have delimited data. So let's go back to that junk program that I had. Now it's junk.csv. You can see what it looks like down here. So we're going to add a couple options to the in file statement. I've specified lrecl. This is not really necessary unless you have very long lines, as I indicated earlier. Anything over 256 bytes, you got to use this. Otherwise, it's not necessary. DSD means that you want to have delimited input, trunk over you want to specify. So if some lines are shorter than others, sometimes SAS gets confused. What I'd recommend when you use delimited inputs is to specify an in format statement. So in format is going to tell SAS what formats these variables will take. So color is $5 dot, just as we had in the previous slide. Amount, notice I've stuck $signs in, so we got to call that $8 dot or $6 dot. Actually, 6 dot would also work. Then input. So this in format just says here are the formats to bring these variables in. Input specifies the order. So first you'll find color, then X, then Y, then amount. I'm going to give another format statement. This format statement tells how to print the variable. So whenever amount is printed, it will be printed as $6.2. And sure enough, that's what happens down below. One word on ordering. Notice that the order of the variables is different than on the previous slide. So previous slide, it was color XY amount. Here it's color amount XY. Why is that? Well, SAS stores the columns in the order in which they are mentioned. So first color is mentioned, then amount, then, okay, well, we've already mentioned color, then X, then Y. We've already mentioned amount. So that's why amount comes first, because amount is mentioned before X and Y down here. And likewise in the proc contents, amount will be the second variable in that contents if you list them by position. Let's now talk about a few more ways to make your data set a little bit better. So I'm going to bring up, actually I'm not going to bring up, remember in SPSS you can specify variable labels, not value labels, variable labels. So these variable labels get printed with a variable. Here's how you specify them in SAS. You add a label statement to your data step. So in this little example, let's say color is really the color of your car. X is the number of dogs that you have. Y is your favorite number. And amount is the dollar amount of your last purchase at my store. So if I read that in, those labels get associated with these variables. And when you run proc means or proc freak or whatever, those labels will now appear with the variables and make the output much more readable. In SPSS, this is what you use to specify that. You just say variable labels, list them. One difference is you don't put an equals sign in, so you just say color space, quote, color of car, and then again you end it in a period rather than a semicolon. Mention the length statement for now. We're going to come back to this probably in the last week of class. The length statement specifies how much space a variable occupies in the SAS data set. By default, all numerical variables will have a length of 8 bytes. So it means it uses up 8 bytes for every row and every variable that's one of these numeric variables. That very often with numbers, you don't need that level of precision. So that gives you something like 15 accurate digits of precision. So if you have a Likert scale that takes values 1, 2, 3, 4, 5, you don't need an 8-byte reel to store it. So you can save space if you have a very large data set. So lots of rows, lots of columns. You can save space by reducing the number of bytes allocated to any numeric variable. You do that with the length statement. So in this case, X and Y take a very small number of values. So I've declared them as 3-byte reels. And so when you do a proc contents on that, what you'll see is that they only use up 3 bytes. Don't mess with this until, unless you have to. So if you have a very large data set, then you want to, probably set them to 4 bytes. 3 bytes. More on this when we get to optimizing your code in the last week of class. It's also used to declare a variable, and so sometimes we'll need to do that beforehand. So I mention it to you now. So you'll see my program's getting a little bit more complicated. We have a length statement, then an input, then a label, and the data lines. Another way that you can bring in data is with proc import. So proc import is going to take a guess as to how you want to bring the data in. It's not as I usually find myself going back to coding a data step, but sometimes import is good enough. And by the way, if you have an SPSS or Excel file, you're going to have to use import. So if we go back to the Unix prompt, you're going to notice that I also gave you case12.sav, that's an SPSS data set. There's a case12.xls, which is the Excel version of that. So these data sets all have exactly the same data in, but they're just stored in different formats. So how would I get in that case12.sav? The answer is you're going to use proc import. Here is the syntax, and I'll just walk you through it. Proc import, data file specifies the physical location of that file on the disk. So I'm going to go back to Unix, make this window a little bit smaller, and what you will see is that we're going to make it smaller yet. If I do a PWD, I'm in SSCC datasets IMC498, and here is that file, case12.sav. So that's the physical location of the file. dbms equals save. What that means is that this is a .sav file. So use your SPSS import engine to get that in. Replace means overwrite any existing data set, SAS data set. The name of the output data set is going to be case SPSS. So we're going to just stick this in work for now. The replace means that if I've already got something in work called case SPSS, it's going to overwrite it, and it's not going to complain. Now, you can also use proc import if you have a delimited file. So if we have a comma delimited file, this command is identical, except I change the name of the file. That's the CVS file. And we have to change the dbms command to be type CSV. The tab delimited file, everything's identical, except you're going to say dbms equals tab. And if it's an Excel file, an old Excel file, you're going to use dbms equals XLS. On PC SAS, there's another way to bring in new Excel files. This is an old one. It's just XLS. It's not XLSX. PC SAS offers you a pretty slick way to bring in one of these new files. It doesn't seem to work on Unix. So if you've got an Excel file, you're going to have to do a file save as. Save it as one of these old Excel files, and then bring it in that way. Note in SPSS, you can also just do a file save as, pick SAS format, and that will write it out. And very often that will work better. Well, sometimes it will work better. I guess I tend to use the proc import. A few more commands that we really haven't talked about. One is proc rank. So proc rank is the equivalent of rank cases in SPSS. So I'm going to bring in the numbers 0 through 9, and I typed them in pretty random order. So here's what it looks like, right? So 5's the first one, then 3, then 6, then 8. Now proc rank will assign all observations to a quantile group. Let's talk about the format. So first, proc rank data equals temp. The temp comes from this data set name. Groups equals 3. means I want 3 groups, so find me the tritiles. If I'd said groups equals 10, I'd get deciles. Groups equals 4 would give me quartiles. Out equals temp. That means I'm going to overwrite the original data set. So the original data set was temp. We're going to overwrite that. Okay, what variable do you want to find ranks of? Well, let's find ranks of x. What do you want to call the ranked variable? Well, we'll call it x3. If we print it, here's what we get. So what you'll see is that values 1, 2, and 3 all get assigned to tritile group 0. And the next 3 numbers, 4, 5, and 6, all get assigned to group 1. 7, 8, and 9 all get assigned to group 2. So that's what proc ranks does. One more thing. Sometimes when you have a lot of variables, you don't want to type each one of their names. You can specify a range of variables using either the dash or the double dash in SAS. So let's talk about dash. What dash means is count. So if I said x1 through x3, what that means is count x1, x2, x3. If I said x1 dash x5, it would be x1, x2, x3, x4, x5. I'm just counting. Double dash, on the other hand, specifies a range of columns. So x1 double dash x3 is columns x1 through x3. So let me give you a little example to make this distinction clear. I'm going to read in a data set, data my data, and I'm going to bring in 4 variables. The order of these variables is as follows. First, we're going to bring in x1, then x2, then height, then x3. So the order of these variables will be exactly that. So if I do a proc contents with position, the first variable in my data set, think of an SPSS data set has these columns going across. The first column is x1, the second one is x2, the third is height, the last column is x3. By the way, you'll note that all have length 8. Why is that? It's because I haven't changed the lengths of these variables, and by default any numeric variable gets 8 bytes. This position tells the position on the logical line. We start counting at 0, so x1 begins at 0, x2 begins at 8. So x1 really occupies bytes 0 through 7 on the line, then x2 is 8 through 15, and so forth. Now, let's do a proc means, and I'm going to do proc means on variables x1 dash x3. Here's what I get. I get counting, so x1, x2, x3. Whereas if I say x1 double dash x3, I'm going to get column x1 through column x3. And notice height is in that range. So that's the difference between dash and double dash. These are super useful. SPSS has something similar, which is 2. You could say x1, 2, x3, the word TO. And here are some exercise problems. I strongly encourage you to do those exercises at this point.